Hi, good day. Welcome to Software Engineering Tutorial session. Today in this session, I will be taking a sheet called function point. So today's sheet will be function point metric. So in this sheet, we have total 5 problems. So this problem 1, 2, 3. Okay. Problem 4 and 5 is continued. This is a problem 5. Okay. So in this session, I will be solving all these 5 problems on the function point. So let me share the screen with you so that you can see what I am writing. I hope you are able to see the screen in front of you. So let's begin with. Yeah, before I start, what is a function point? Let me give you what do you mean by function point analysis? Okay, what is the use of this function point? So FPA, this is sheet. You're able to see my screen, yeah. This is okay. So today I'll be discussing function point analysis. Function point. Function point. So what is FPA? FPA is nothing but function point analysis. Okay. Now, what is this function point analysis? It is designed to estimate and measure the time and the cost of developing new software applications and maintaining existing software applications. So the use of this function point analysis is to estimate the time and cost of developing new softwares applications at the same time maintaining existing software applications. Normally, it's very easy for us that if you take a pen, then what is its cost? You can estimate it. Okay. If you have a car and you want to sell it, you can just give a quote how much you want to. But if you have developed a software, then how do you quote it? How do you, find the cost and how do you estimate the time? For this, we use function point analysis. Okay. It is useful in comparing and highlighting opportunities for productivity improvements in software development. It was developed by A.J. Albrecht of IBM Corporation in early 1980s. So the main other approach used for measuring the size and therefore the time required of software project is lines of code. Okay, so what is lines of code? Which has a number of inherent problems, but in the syllabus we'll see this. So there is a concept called LOC, is nothing but lines of code. What is there in lines of code? Okay, in lines of code you have suppose you write a program. Okay, this is your program. Okay, so this program is nothing but it is set of instructions. It is set of instructions. Okay, so line of code is nothing but a instruction which is an executable. Okay, it is an executable instruction. What is not line of code? What are the things which are not line of code? Okay, in program you write comments. Okay, and you have spaces, line spaces. These are all not they are not considered in lines of code. Okay, etc. So like this set of programs is called a software. So what is software? Software is nothing but it is set of programs. Okay, so we have some formulas and kind of stuff for measuring, estimating the time and cost for developing a new software and also maintaining the existing software applications. So I hope the definition is clear to you. Now we'll go to the next problem. So let me save it. And this is the first problem. What is line of code? Just now we have seen LOC is nothing but a line of code, which is an executable instruction. What do you mean by an executable instruction? An instruction which is executed by the CPU. Okay, so let's write the solution. It is a line of code. Okay, it is an executable instruction in a program. Executable means executable instruction is nothing but an instruction which is executed on CPU. Which is executed on CPU. Okay, so now he has said that there is some model. It's given here that some model uses an equation of the form. This is the equation given. E is equal to 2.7 KLOC. Okay, what LOC is line of code, KLOC is nothing but kilo line of code. Kilo line of code. Okay, so here equation is given as E is equal to 2.7 KLOC whole to the power of 1.05. Okay, now here you need to understand some couple of things. What is E here stands for effort. Okay, and this is kilo lines of code. You know that 1 kilo is nothing but 1000, right? So given lines of code is here given. Find the effort taken. You have to find E. You have to find E in person months or man months. The unit of effort is what? Unit of effort is man month or person month. Both are same. So he has given that if the total lines of code are 50,000, so it's given, okay, LOC lines of code are 50,000. Now I will convert it into KLOC is 50. Okay, so suppose I take this as an equation 1. So let us put this value in equation 2. Put 2 in 1. So I get effort E is equal to 2.7. So value of KLOC is 50 whole to the power of 1.05. So you can use the calculator, scientific calculator. So it will give you answer. So if you use the calculator, I think you'll get 164 point something. 16564. Okay, so what is this? Therefore you got effort is equal to, so I take round number, 164 man months or person months. Now he has given if each man month, okay, I can write this man month or person month, both are same. Is given that if each man month incur to take fixed amount of $5,000. So he has given again that if one man month is taking $5,000. Okay, see the question. If each man month incurs to fixed amount of this, find the cost of the project. So you have to find the cost of the project. So how do you find out the cost of the project? So you have to find out for 164 person months how much dollars. So 164, okay, man months, how much? This will give you the cost of project. Okay, so therefore we write that the cost of project is 164 multiplied by $5,000. This man-months get cancelled. Okay, so this will be equivalent to, therefore cost, I think this is equivalent to nearly 82 four zeros. US like 82 million dollars, or 82,000, 8,20,000 dollars. Okay, this is $8,20,000. Cost of the project is $8,20,000. Okay, so this is your first solution. We found the cost of the project. So let's go for next slide. What is FPA? Show diagrammatically FPA, functional point units. Now, so how this function point analysis is done? Working from the project design specifications, there are some system functions that are measured or counted. They are called inputs, outputs, files, inquiries, and interfaces. Okay, so these are this is how the function point analysis is done with the help of this important what do you call as specifications. Okay, so function point units are, so I write here, function point units are okay, you have inputs, you have outputs. Okay, that is coming into the system is called an input, that is leaving the system is called an output. Okay, so inputs are nothing but information entering the system. It's nothing but information entering the system. Output is nothing but information leaving the system. And similarly, you have total 5 functional point units. Okay, another is called inquiries. This is a request for instant access to the informations. Request for instant access to information. And finally, you have internal logical files. ILF. Internal logical files. Okay, that is information held within the system. It is nothing but information held within the system. And finally, you have external interfaces. IF or EIF. It's called external interfaces. What do you mean by external interfaces? This information held by other system that is used by the system being analyzed. This information held by other system that is used by the system being analyzed. Okay, so we can show the diagrammatical representation of this also. So let me show how these are related. Yeah. So if you assume that this is the user, and you have multiple users, user 1 and some say another user 2, and this is the internal logical files. So user can inputs, information entering the system, information leaving the system is the output, and inquiries, this bidirectional. This is inquiries. And you have some other applications. They are called other applications. And you have some external interfaces also. So ILF is internal logical files, and EIF, this ILF, this EIF is external interfaces. This is nothing but, this is the figure name, let's give FPA, functional unit system, function point analysis, functional unit system. Okay, so I hope this is clear. So what is FPA? We are showing that diagrammatically FPA functional units. So let's go to next problem. This problem number 3. Yeah, before seeing this problem number 3, we need to understand some couple of formulas. What are those? Let me tell you. Yeah, this is, yeah. So let me select the color. Okay. There are some couple of formulas we need to understand before we go for solving this problem. First is what do you mean by FP? FP is function point, we know well. So I'll write the formulas here, this side, so that you can understand. So function point is given by the formula called UFP, and this added with CAF. So let us understand what do you mean by FP. FP is nothing but function point. UFP means unadjusted function point. CAF is nothing but complexity adjustment factor. Complexity adjustment factor. So again, you need to understand what do you mean by UFP. Okay. So UFP in turn is nothing but summation of function point units as follows. How do you write it? For example, in a table you have row and column. So I'll just suppose you have a row. This sigma is talking about I is equal to 1 to all the rows. So total how many rows am I having? 1, 2, 3, 4, 5 rows. Okay, 5 rows. And another sigma is talking about columns. So j is equal to 1, 2. How many columns you see has given? 1, 2, 3 columns. Okay, 1 to 3 columns. So here you have to do multiplication of ij and w of ij. What do you mean by this? Let us understand. W of ij is nothing but entry of the ith row and jth column in the table. What is this? Entry of the ith row and jth column in table, and zij is nothing but this is the count. These are the counts. How many? Okay, 3, 4, 5, 10. How much? This is the count. This is count of the functional units. Functional units of I, this I, that have been classified as the complexity corresponding to the column in J. Okay, units of I that have been classified as having the complexity corresponding to column J. So might be because this is theoretical, you might not understand. When you solve the problem, everything will be clear. Okay, So you see here, he has already given the number of user inputs. So I just denote this as inputs as I, and this is outputs as O. Okay, user inquiries as Q, for example, and number of user files is ILF, internal logical files. External interfaces, I'll just give it as EIF. So these are actually our 5 functional units which we have seen in the problems, right? So all these 5 are given here, okay? So here he has given inputs, outputs, inquiries, and internal logical files and external interfaces. He has given some shortcuts, EI, EO, EI. I'm just taking this for by convention to solve the problem. And you see, this is weighing factor. He has given the weighing factor for low, average, and high. Instead of low, it may be using sometimes okay simple, okay, then high. There are different other terminologies also possible for this. For example, in case here he has used low, average, and high, we may use instead of low, it may use simple, medium, and complex. Okay, they may use anything. So instead of low, they may use some simple or medium, and complex also can be used. So both of them are having same meaning. Now another important thing is, see each of these functional units, I is having a weighing factor. In low category it is 3, in average category it is 4, and in high category it is 6. Okay. Similarly, for output it is 4, 5, 7. For inquiries, okay, it is 3, 4, and 6. For internal logical files it is 7, 10, 15, and external interfaces it is 5, 7, and 10. Okay. So this is given, and he has given another important thing is assume all complexity as adjustment factors. What is this complexity adjustment factor? Your CAF. What is CAF? This is complexity adjustment factor. Okay, and weighing factor also. Weighing factor. What is weighing factor? This is weighing factor. Okay, this weights. He's asking us to take an average. Average means we'll be taking only these values, average values. Okay, so compute the function point for the project. So he's asking us to find out FP. So now he's asking us to find out FP. Find FP. So for finding FP, you have to use the formula. Just now I have given FP is equal to UFP plus CAF. Yeah, there is a little change. Please make sure that it is not UFP function point FP UFP plus, not it is plus, this is multiplication. Please remember, this is multiplication. UFP multiplied by CAF will give you the answer. Okay, so this is multiplication of this. Now, how do you find out? How do you find out UFP now? Okay, so let us use this formula of UFP. Okay, for finding functional point unit. So let us find out first UFP is equal to, okay, so now you see for all columns multiplied by the weighing factors J, okay, you have to do, for example, in columns first I have input I, okay, you have to multiply it with weighing factor, okay, weighing factor is average, okay, so for I, what is the weighing factor average? 4, plus then you have outputs and average weighing factor is 5, plus inquiries weighing factor is 4, plus internal logical files its weighing factor is 10, 4, 5, 4, 10, then 7, plus external interfaces multiplied with 7. Okay. Now, when you got this, the value of, you see, I, O, everything are already given here. I is 50, O is 40, 50. Let us just substitute that value. 50 into 4 plus 40 into 5 plus 35 into 4 plus internal logical files are 6 into 10 plus 4 into 7. So this will give me 200 plus 200 plus 35 into 4, 20, for the 12, 13, 14, 140 plus 60, 7 for the 28. So 400, 500, 628. So therefore, you get UFP is equal to 628. Okay, 628. So this is not over because we have only found half of it. So still there is some more things we need to find out. Let me just increase. Okay. So FP is found. Now we have to find out, UFP, unadjusted function point. So let me write this also. UFP is nothing but, okay, I think already I have written unadjusted function point. Yeah. So now we will find out now complexity adjustment factor. Okay. So therefore, UFP is equal to 628. Now let us find out complexity adjustment factor. Now, complexity adjustment factor is given by the formula. You must note down this formula, it's very important. What is the formula for complexity adjustment factor? So let me explain you here. See, complexity adjustment factor is nothing but 0.65. This is a constant added with 0.1, okay, multiplied with summation of I is equal to 1 to 14 Fi. So there are 4 factors that are influencing the complexity of the project. Okay, they are already fixed. They are given. There are 14, factors that affects. So this F is nothing but the degree of influence. It is called as degree of influence. Now this degree of influence, how do you find out? From the graph of degree of influence. Let me just write here. Not graph, from the picture which I will give you now. See, this is the degree of influence. This is the scale for degree of influence. We have a scale. Okay, now this is at 0 and this is at 5. In between you have 1, you have 2, you have 3, you have 4. Okay, so what do you mean by 0? 0 means no influence. Okay, 1 means incidental. Okay. Then 2 means moderate. 3 means average. 4 means significant. And 5 means essential. Very important. It means it is important, is very important. So this is degree of influence. This is very important. You should remember this. Okay, for all the problems, this is very important. So I request all of you to just note down this degree of influence chart. Now from this, it will be very easy for us to find out the complexity adjustment factor. So how do you find out complexity adjustment factor? So it is given that it's given by the formula that 0.65 plus 0.1 into sigma I is equal to 1 to 14 Fi. It means this can be rewritten as 0.65 plus 0.1 multiply with F1 plus F2 plus F3 plus up to F14. This is the meaning of sigma, right? So he has given that, just note down in the question, the complexity adjustment factor and weighing factors are average. He has given average. So weighing factors already we have taken average. For complexity adjustment factor, we have to take an average. Average means 3. So the value of this F is 3. How many? 14 times. So we write 0.65 plus 0.1 into 14 times 3. All average, that is 3 plus 3 plus 3 plus 3, 14 times. Okay, so this will be 42. So 0.65 plus 0.1 into 42, so this will give you 0.65 plus 4.2. Please correct the formula. I think this is not 0.1, but it is 0.01. Okay, so this should be, so let me just modify this formula. This is 0.01, okay, because it will not go beyond 1. Okay, let me see. Yeah, so 0.01, 0.01, 0.01. So this will be how much? 0.01 into 42 will be 0.42. Okay, so this will be 0.65, 0.42 will be 7, 10, 1.07. So therefore, complexity adjustment factor is equal to 1.07. Therefore, function point Fp is equal to UFP, unadjusted function point, multiplied by complexity adjustment factor. So this was 628 multiplied by 1.07. So if you do it, so you will get, therefore, for nearly, I think, 6 71.96. So therefore I can take function point equivalent to 672. Okay. If it is more than 0.5, you can take the next number. If it is less than 0.5, let's take the lowest number. Okay. So this is how we got the solution. So hope you have understood. So let's go for problem 4. Now it will be very easy to solve it. See, an application has the following: 10 low external inputs, 12 high external outputs, 20 low internal logical files, 15 high external interface files, 12 average external inquiries, and a value of complexity adjustment factor of C 1.10. The good news is he has given the value of complexity adjustment factor is given as 1.10. Okay. What are the unadjusted function points and adjusted function point counts? Use the required data from problem 3. So I have just taken from problem 3 the same table. So table may change. Depending on the table, you have to calculate it. Okay. So you have to find out function point and also unadjusted function point. He's asking us to find out UFP and also FP. So we know that FP is equal to UFP multiplied by CAF. CAF is already there. You have to find out UFP, unadjusted function point, which is same as, yeah. Now in this case, you see he has given in different way. We have first inputs. Okay, I is for input. So he has given inputs. Inputs are 10 low. Okay, so inputs are 10 low. So input is given as, let me just write down first. Here, it's given me I as 10 into, this is low. This is the value of I he has given. So for 5 components, we'll write. Okay, input, then you have output. For output, he has given 12 high external outputs. So 12 into high. Okay, then inquiries Q is equal to, where is inquiries? So you see here is the inquiries. Okay, 12 average external inquiries. So 12 average again external inquiries. Then you have ILF, internal logical files, and external interfaces. Okay, so for internal logical files, 20 low he is giving. 20 into, this is low, and 15 high external interfaces. 15 high external interfaces. Okay, so now let us fill this from the table. Inputs, this is I, input is low, low is 3. Output, here is output, high, high is 7. Then inquiries is 12 average, this is inquiries, average is 4. And internal logical files, low is 7 here from the table. And 15 external interfaces is giving high, high is 10 from the table. Okay, so from this we got that I is equal to 30, O is equal to how much? O with this weighing factor, is how much? 12 into 7. Let us use the calculator. Okay, so 12 into 7 is 84. Then 12 into 4 is 48. 140. 150. Okay, so now we have got the phases. Now UFP is given by all rows, all columns, okay, which is equivalent to here. See, this is all rows and these are columns. We have already did this multiplication, we got this. So how much? 30 plus 84 plus 48 plus 140 plus 150. Let us use the calculator. 30 plus 84 plus 48 plus 140 plus 150. So you got 452. So therefore UFP is 452. Why? Because you have got this total as 452, right? So now after getting this, come back and let us find out function point. FP is equal to unadjusted function point multiplied by complexity adjustment factor. So UFP is 452 multiplied by complexity adjustment factor is given as 1.10. So 452 multiplied by 1.10, this will give you nearly 497.2. So therefore we take function point is equivalent to 497. Okay, so we solve the problem. The good point was complexity adjustment factor was already given. This is your problem number 4. So hope you have understood. Now let's go for problem number 5. This problem number 5 is also taking the same table. I'm showing you on the same table so that changing table is of no use because it has nothing to do with the logic what we are using. Yeah. So now let us try to solve this problem. Problem number 5 is already given. Consider a project with the following parameters. See, we are finding FP. When once FP is found, cost of the project is very easy, as I have told you that if a certain project is taking 20 function points, what is the cost of the project? If one function point is equivalent to some $10,000 like that, so you can just easily solve it. So important is how do you find FP? Okay. So that's why in all the problems I'm showing you the FP, function point calculations. So let us go for the last problem, problem number 5. Now this is a little complex. Here we have to find out everything, CAF, UFP, and everything is changing dynamically here. So let us see what he has given. Consider a project with the following parameters. External inputs. You see, for inputs he has given 1, 2, 3 parameters. Okay, so what we'll do is Let us solve it. For solving. Yeah. So here in this case, you see he has given inputs. Let us write here inputs. For 5 functional units, I have to write down. Here it's for inputs. Okay. Now see, for inputs, he has given. So write it. For inputs, he has given 10 low, 10 low plus 15 average plus 15 average plus 17 high complexity. Okay. Now, how do you find out this? So you see from the inputs, okay, low is 3. Just filling out this. Low is 3, and input average is 4. For input high is 6. Okay. 10 into 3 is 30 plus 15 for the how much? 60 plus 17 into 6 to use 17 into 6 is 102. So therefore total is how much? 102 plus 60 plus 30 is 192 you get here. Okay. For inputs we got this. Let us find out for outputs. There are 5 functional units. Okay. Now for outputs also we will write here. You see for outputs 6 low, 13 high. 6 low plus 13 high. He has given only two things only. So let us solve from this table. For outputs, low is 4, high is 7. So 6 4 is 24 plus 13 into 7 is how much? 91. So 91 plus 24 is giving you 115. So finally we got the value as 115. Okay. Okay, 115. Okay, just this minute here. So it has given me total of 115. Okay, so now let's find out for inquiries now. Now see, for inquiries, for inputs, outputs, for inquiries he has given 3 low, 4 average, 3 low, 4 average, 3 low complexity, 4 average complexity, 2 high complexity. 2 high complexity. Okay, so let me fill this value For inquiries, low is 3, 4, 6. 3, 4, and 6 from the table. Inquiries low is 3, average is 4, high is 6. So now this is 9 plus 16 plus 12. How much is it? 9 plus 16 plus 12 gives you 37. Okay. So similarly, we have internal logical files. Now for internal logical files, you see, yeah, internal logical files. Internal logical files, yeah, he has given here internal logical files. 2 with average complexity, 1 with high complexity. Okay, so 2 average, 1 with high complexity. So let's see internal logical files. Average is 10, high is 15. Okay, so this is 20 plus 15 is equivalent to 35. Okay, now similarly we will find out for external interfaces. For external interfaces, he has given only now with low complexity. 9 with low complexity. So 9 with low complexity. So 9 5 is 45. So you have got total 45. So what is UFP, unadjusted function point? We know that for all rows 1 to 5, for all columns 1 to 3. Okay, Zij, Wij. Weight and the columns already we have multiplied here, we got it already. So this is equivalent to nothing but 192 plus 115 plus 37 plus 35 plus 45. Okay, so let us use calculator. 192 plus 115 plus 37 plus 35 plus 45. For me it's giving 424. Okay, you can use calculator and verify the results. Therefore you got UFP is equal to 424. Okay, now the next hurdle is to find out, in addition to the above, UC is given. Okay, the system requires, yeah, he has given significant data communication, performance is very critical, design code may be moderately usable, system is not designed for multiple installations, other complexity urgent factor, treat this as average, compute the function point for the project. So now we have to find out the function point now. Okay, so for here, so let us find out complexity adjustment factor now. Okay, so how do you find out the complexity adjustment factor? It's very simple. Complexity adjustment factor is given by the formula 0.65 plus 0.01, okay, multiplied by 1 to 14 Fi, degree of influence. Okay, so now also we know the scale. Just to remind you again, we have an scale 0, 1, 2, 3, 4, 5. Okay, this means essential. This means significant. This is average. This is moderate. And this is incidental. Means has no influence. So from this we have to find out the complexity adjustment factor. So we can rewrite this as 0.65 plus 0.01 plus this is F1 plus F2 plus F3 plus F4 plus F5 plus up to F14. Okay, now but here you see has given F1 is given F2 F3 F4 up to F4 he has given. Okay, so it means let us write out 0.65 plus 0.01 is multiply this bracket. F1, what is F1? Significant data communication. Significant data communication means 4 plus F1 is finished. Next is second is performed is very critical. Very critical means 5, very important. Then 3 is design code may be moderately usable. Moderate means 2. Then fourth is system is not designed for multiple installations, means it has no influence, 0 plus. Now you see out of 14 1 2 3 4 is given, remaining are 10 are all, remaining all are average, so I write 3 into 10, all are average, remaining are average. So you have 0.65 plus 0.01. Okay, so 4 plus 5 9 10 11 11 plus 30 41. Okay, so 0.65 plus 0.41. So 0.65 0.41 is how much? 6 10 1.06. So therefore complexity adjustment factor is 1.06 you have got. Finally, therefore you can find out function point is given by unadjusted function point multiplied by complexity adjustment factor. Unadjusted function point is 424, which is multiplied by complexity adjustment factor is 1.06. I think we have to use the calculator to get it. So 424 multiplied by 1.06 gives 425. 425.02. Is it the same we have got? Okay, so just check it out. 424 into 1.06, how much? 424 into 1.06 is, I think it's 449, right? It's not this. Again, 424 into 1.06 is 449.44. So therefore, we take function point equivalent to 449. Okay. So this is how we solve for the function points. So with this, we have finished our sheet function point. Okay, and see you next week. Inshallah.